Okay, in this lesson we're going to have factoring special cases. We're still dealing with quadratics. We still have an x squared or an a squared, second degree lead term. But these are going to look a little different than the ones you're used to looking at. So if you take this binomial and you square it, that's going to mean a plus 3 times the quantity a plus 3. That's hard to remember. Many people want to say that is a squared plus 9. It's not. You're going to factor that and it will turn into a quadratic, which usually will have 3 terms. Now also, just remember, if you have x squared, that's the same as x times x. Well, this is an object squared, so you have to take that object times itself. Same patterns, same rules we've been learning since day one. Now, hopefully you remember how to multiply two binomials. You can either use the FOIL method, which says multiply your first two terms, then your outer terms, then your inner terms, and then your last two terms. And then the outers and inners are most always common like terms, so they will combine, and that's going to turn into a squared plus 6a plus 9. Now if you look at 9, what is the square root of 9? That's 3. And what is 2 times 3? That's 6. Now go back to our original thing, our original binomial. 3 squared is 9, and 2 times 3 is 6. This is called a perfect square trinomial, because when you factor it, it turns into a perfect square, which is what we started with. So when you're factoring these, you're actually going backwards. So for instance, if we had x squared plus 2x plus 1. So if you look at that and you say, what's the square root of 1? That's 1. And what's 1 times 2? Well, that's 2. Well, when you factored that backwards using either the parenthesis method or backwards FOIL, you know, like all those we did on the last lesson, or the AC method, you're going to see that that's going to factor to x plus 1 times x plus 1, and that's going to equal, when simplified, x plus 1 quantity squared. That is the hardest perfect square trinomial there is, because for some reason we cannot see that 1 times 2 is 2. So if you go to the next one, which would be 1 squared, 2 squared, so we'll have a 4 at the end. So we start with x plus 2 squared. Well, if we were to expand that out, we would get x squared plus 4x plus 4. That one's confusing as well. When you first see it, it's hard to recognize that it's a perfect square trinomial. But what's the square root of 4? 2. And what's 2 times 2? 2. So therefore, if you recognize that relationship, you can factor that directly to an x plus 2 quantity squared. So what if we were using bigger ones? Let's say we had this one. If you will recognize that the square root of 36 is 6, and 6 times 2 is 12, you can immediately change that to x plus 6 quantity squared and save yourself a lot of work. So what about this one? See if you can do it on your own. Look for the relationship of the square root and the double, and that will factor directly to x plus 7 quantity squared. Now it's no big deal if you don't see that relationship, because you could still use the two methods that I taught you in the last lesson. 49 is either 1 times 49 or 7 times 7. Well, definitely 7 and 7 get you 14. Everything is positive, so our factors will be positive. And right there you have to recognize that that's going to simplify to x plus 7 quantity squared. You'll still get there, you'll just work a little harder. And if you use the CAS method on that, the AC method, it's x squared plus 14x plus 49. A times C is 1 times 49, which is 49. Well, now we want to know what times what is, now we want to break this up into factors that equal 14, which is 7 times 7. So we will rewrite the middle term. Remember, I told you that's the step you always want to forget, is rewriting that middle term. And now we're going to group it. Now the first one, we have a common factor of x. The second one, we have a common factor of 7. And now we have a common factor of quantity x plus 7. And when you take that out, it leaves you x plus 7. You'll still get there any way you go. But we have another special case, which is called the difference of two perfect squares. And you'll see these a lot. And if you look at number 1 on 5-3 factoring special cases, number 1 is 16x squared minus 1. Well, 4x times 4x is 16x squared. And 1 times 1 is 1. And the minus says it's a difference. So these are both perfect squares. Here's a perfect square, and here's a perfect square, and it's the difference of two perfect squares. So if you can remember this rule, which looks like this, if you have a squared minus b squared, that immediately factors to a plus b, a minus b. Now in this instance, our a is not 16x, but it's what is being squared. Well, our a is 4x squared, and our b is 1 squared. So if you can remember this shortcut, you can immediately say that's 4x plus 1, 4x minus 1. But now let's do this the long way to prove it to ourselves. So we have 16x squared minus 1. Remember, quadratics are written ax squared plus bx plus c. This is hard because we have no b. So really what you're looking at is ax squared plus 0x plus 1. This is a placeholder. So when you're doing your factors, whether you use the AC method or the other method, what you're trying to have is two factors that will combine or add up to 0. So these are tricky. Well, let's just use the AC method. So A times C is 1 times 16, which is 16. All right, now what are the factors of 16? Well, obviously 1 times 16, or 2 times 8, or 4 times 4. Where are we trying to get? We're trying to get to a 0. 4 and 4 will get us there. So the second step is you're going to rewrite. So 16x squared plus 4x minus 4x minus 1. Now what is the inside or the two middle terms combined to? A 0. 4x minus 4x is 0, and that's exactly where you're trying to get. So now we're going to take our normal methods, we're going to group them, and we're going to factor by grouping. So in the front set, the only common factor is a 4x, which leaves you with 4x plus 1. The second factor is tricky because the only common factor is a 1. If you notice, we are trying to get this to be identical to that factor because we need to actually factor that out later. So let's look at what happens when we take a 1 out of here. That's going to leave us with, we're going to take a positive 1 out, not a negative. So this is going to be positive, not negative. Okay? So if we take a positive 1 out, that's going to leave us inside with 4x minus 1. These are not the same, are they? That's how you know you need to go back and take out the negative 1. Because your goal is to get these two pieces the same so that you can factor it out the second time when you use the AC method. So this minus sign between them is a little misleading. It really needs to have the minus sign inside that parenthesis for you. Now what are we going to take out? A negative 1. So when you divide negative 4x by negative 1, that leaves you 4x. And when you divide the negative 1 by negative 1, that leaves you a positive 1. So when you factor out a negative, you flip that sign. Now our common factor is 4x plus 1. And that's what it changes to. So that was an awful lot of work and very confusing with these positives and negatives. So it's a lot easier to remember this rule. There you can see we got the same answer. The difference of two perfect squares. So let's look at number 7. Number 7 says 9x squared minus y squared. Well, what is that actually being squared in the front? Isn't that 3x quantity squared minus y squared? And remember your rule, a squared minus b squared equals a plus b, a minus b. So your a is 3x, and your b is that y. That's going to turn into 3x plus y, 3x minus y. So every time you're looking at quadratics, the first thing you need to look at is, first off, if you have a binomial, are they two pieces being squared? Kind of hard to find sometimes. And then if you have a quadratic trinomial, is it a perfect square trinomial? So does the square root of your constant equal twice your middle term? And if it does, you can skip directly to that end result of the square root of that constant being inside your binomial. Now, none of this is the end of the world if you forget these rules, but as you can see, when you have these special ones, the AC method or the trial and error with parentheses are a little difficult. Now let's go look at number 19 on page 2 of 5.3, factoring special cases. So on number 19, we have 5xy minus 5x plus 8y minus 8. So first off, we don't have a trinomial. We don't have anything quadratic. It's a weird looking expression. But I do notice that I have a common factor in the first two, and I have a common factor at the end. So my common factor in the first two is 5x. Well, when you take out the 5x, that'll leave you with y minus 1. And the common factor in the second group is an 8. Take that out, you have the y minus 1. And now this is just a normal old factor by grouping like we did on the last lesson. Take out that y minus 1, and when you do, it leaves you with 5x plus 8. So this should be enough to get you through factoring special cases. Good luck.